Welcome everybody to our July installment of ENERCALC Office Hours. For anyone who's new here this month, Office Hours program is meant to provide direct line of communication between us and our users, and that kind of relates or involves several things. Mainly, we're showcasing new features, updates from ENERCALC, showing optimized design workflows. We always have a regular segment where we answer questions that were submitted ahead of time. So if you're on our email chain or you see our stuff on LinkedIn about office hours, we always encourage you guys to send those questions ahead of time so we can cover those in office hours. We will have time for live Q&A, and then we do hands-on examples as well. So, and if there's a question that's too involved or requires troubleshooting, that's a better fit for our support team, and they can help investigate any issues that you have there. With that, I will go ahead and hand it over to Mac, who's sharing his screen right now, and he'll get going on our program for today.
Hello, everyone. Thank you, Seth, for the introduction. And without further ado, I'm just going to jump right in. The first thing here that we want to talk about, I'd like to start our session with a brief overview of the overall agenda for today. And we will be covering ENERCALC's latest build, register for office hours to get notified. We will also cover workflow tips and tricks. Specifically, we're going to talk about the multiple simple beam module. And then we will cover prepared Q&A. Those were previously submitted by users. And then we're going to jump into the main course of the presentation today, which is the live and dynamic load linking, which is our newest feature. And then lastly, we will jump into live Q&A. So we have a couple of housekeeping items that we want to go over. So the first question is, are you on the latest build of ENERCALC? If you open your ENERCALC and look at the very top, you will find your current build. And we want to make sure that you get notified of any new updates. So this way you take advantage of the latest and greatest and the new implementations that we have. And we do an update monthly. So all you need to do is you need to click on the update button right here, and then this window will pop up. So just make sure that you check this option. So this way you will always get notified upon the program startup of any new updates. Another housekeeping item that we want to discuss is the build that you're on right now. If you are in this range of ENERCALC builds, which is 2023 830, 2024 228. If you are in between or within this range, then the feature that actually notifies you or automatically notifies you of the availability of new updates does not function properly if you're within this range. Now, if you are at this 2024 3.4 or newer, you don't have to do anything. But if you are stuck in here, then you will need to do a manual update, and you will just do this one time, and you'll be good to go. And the way to do this is very simple. You can either do it from within ENERCALC, or you do it following the enercalc.com/users URL. So the process is very simple. You can do it in 3 simple steps. You just start by clicking on the same updates button that we have right here. And you just click on this button, and that will take you to our website. So that's step 1. Step 2, you just go to our website. It'll take you automatically there. You click on to download this updater. This is the latest and greatest. And once you download it, you run it, and you will be good to go. And then once you do all of this, it's a good idea just to go back, click on the update button again, and just make sure that this is checked. So this way you are always notified of the newest updates as soon as they're released. It's important to note that we are currently on build 2024-0708. That was released 2 days ago. So this is the newest, latest and greatest. So please make sure that you update to that. Registration for office hours. So I encourage everyone to register for the office hours program so you can get email notifications directly to your email. Typically, the email that we have on file is for the IT department or maybe the admin that manages all of the office licenses. Sometimes these notifications, notifications about educational sessions never actually make it to the engineers. They maybe stay with the IT person or whoever is managing the licenses, or even they might go to just one engineer in the office, while the other engineers don't really know about it. So this way, this is why I encourage everyone who is interested in these monthly sessions to register on our website, so they can get notified directly. And of course, you can always unsubscribe as needed. And just to remind you, this is open to everybody, active users and non-subscribers, and everybody's is welcome to join in. And with that being said, you can register by going to just enercalc.com/office hours. So you can just go there, or if you don't want to remember the URL, you can simply access everything from going to our website. So if you go to our website and then click for our users tab, and then select the office hours button from the drop-down menu, that will take you to the registration page. It's a very simple process. You input your email address, you put your name, and if you're an active subscriber, then we ask you to put your registration number or your license number. If you're not a subscriber, don't worry about it. You can leave it blank, and then finally click on the submit button, and you will be included in the email list. Lastly, at the very bottom, we always update the information here regarding our next office hours. So you can see here that this is latest and greatest, July 10th. In a few days, we will update it to the next session that we will be holding. Keep in mind, this is actually a calendar event. So if you actually click on it, it'll download a calendar event. You can just double click it and open it with Outlook or open it with Gmail or whatever you use, and it will go directly to your calendar. And if you ever lose the URL for these sessions, you can always just come to this website and you can click here, and this will take you to the actual event. This also will be updated monthly to take you to the right place, and this way you can stay in the loop. So getting here into the workflow tips and tricks. So I'd like to share with you some tips and tricks that might help you optimize your workflow and increase efficiency. So many structures have multiple simple span beams. This is normal, especially for 1 and 2 story buildings, and most of the time, or a lot of times, you will have a few beams that have the same loading conditions. They might have different spans, and the calculations kind of might get crowded. So if you have 5, 6, 7, 8, 9 beams of the same loading, but just different spans or minor tweaks, creating a new calculation for every one of those might cloud your project manager or your landing page of the software. So that's where you can kind of the multiple simple beam module really shines. So I want to dig into a real life example. So a good example is this framing plan. You can see that the perimeter beams will have the same loading but different spans. You can see them right here, 23, 27, but clearly this is the same loading relatively, minus a couple of openings here and there. And then you also have the same thing for these corridor beams. So these beams right here, they all have the same type of loading, just different spans. And the spans here currently range from 23 feet to 35 feet. So what I want to do, I want to create 2 calculations, one that covers up to 27 feet, and one that covers up to 35 feet. So what I want to do is we want to just jump into the very simple process to open this module. Just like every other module, you go to add and then go to beams. And then for this one, you go to multiple simple beams. And this module can house multiple beam calculations within one calculation. So you can see here at the top, you see beam 1, but you also see this add button right here. And this allows you to create another calculation. And we'll dive into this a little bit more later. So you can also pick your support conditions. This module does simple beams with overhangs. So you can have a little bit of cantilever here, a little bit of cantilever there, but that's about it. Now, if you want, or if you have a complicated multi-span beam, then that would warrant its own calculation, for example, in the steel beam module or the wood beam module or so forth. So this is kind of more limited in the applications, but you can have a bunch of them here in one place, and this will save a lot of time. You can toggle back and forth between them very easily. This module has a typical layout, which is just the normal layout that you expect to see in any calculation module in ENERCALC. So you can start here with the general tab, and you can update here the name of the calculation. for me, I'm just going to call it, beam 1 up to 27 feet perimeter. And you can just continue to add more of the information. If you want to have a little bit more information to describe what this beam is, you can put a lot of info here. And you can move on, just pick on the material for your beam. So this will do wood and steel. So we don't have an option to do concrete. But if you have a bunch of just wood and steel beams that are all simple spans, you can just put a lot of them here. You can really pick all of your typical design information that you expect to see, like FY or ASD versus LRFD, or the same thing with your deflection criteria. You can put all of that information. You can pick it, and then at the bottom you can select your size. You have your library here to pick whatever standard steel beam size that you would like, and you would also get the same type of control that you would get in the standard standalone module. So for example, you get the bracing tab, and this will give you all the information you need. For us in this project, or in this example, we have joists that are spaced at 2 foot 6 inches on center. So I'm going to define my bracing starting at 0 and occurring every 2.5 feet. This is your compression flange bracing. You can, of course, optimize this or do this based on your unique condition. So once you go through this process, the rest of the tabs here are your very typical tabs. You have point load tab, you have the distributed loads tab, and you have load combinations tab. So all of this is your standard process. The new thing that we have here is the description box. So this right here, the name you put here is the name of the calc that shows in the project manager. This name is going to be a description of the set of the calculations. So for example, I'm going to call this second floor area 3 perimeter beams. So when you go and open your ENERCALC, you can see it right here. That's the name that pops up here. So this is not going to say, beam 1 up to 27 feet or beam 2 up to 35 feet. That's not what shows up here. So in the general tab, that description is what you use to differentiate between a beam and another. But in this description tab, that's just the name here. So this way, if you're looking on the second floor north area, you can just put that here, and then you can have all of the calcs there for it. Then you can have another one that says second floor south side or something of that nature, to just help you organize your drawing, your calculations, and know exactly what to expect once you open this. So with that being said, beam number 1, which is up to 27 feet, I went through the process of the calculations and all of that, and we're using a W18 by 40. And so I can come here and annotated it in my plans up to 27 feet. That's what we're going to use, W18 by 40. Now we can move forward and design the other beam that is up to 35 feet. And in order to do that, it's exactly the same process, but now you're adding a second beam. So when you click on add to create a second beam, you can create the beam or beam 2 as a standalone calculation, or standalone by itself here, starting from scratch, or you can create it as a copy of beam 1. To me, beam 1 is exactly what I want to start from, because all I need to do is just change the name and change the span. So I started it as a copy of beam 1. And you can see here, you'll have on the right hand side, you can always delete. If you have a bunch of these 3 or 4, you can just click whichever one you want and delete as needed. So once you go through this process, you update it to 35, and this is beam 2 up to 35 feet. We were able to get a W21 by 57 to work, which is now what we're using on this side. Now, all of your calculations, again, are wrapped up neatly in one calc line, because everything is wrapped up just in this. So when you open this, you'll find 3, 4, 5, 6 calculations. So that's very, very useful, and it just it helps you organize your calculations very well. Now, what I want to do here, and this has nothing to do with the example, but I just wanted to take it a step further. I wanted to go ahead and just design a third beam to just showcase that you can have multiple materials within the one calculation. So if you did steel beam 1 and beam 2 are steel, but beam 3 is concrete, I'm sorry, is wood. So we have here just a wood rafter, 9 feet, and then it has a 3-foot cantilever right here. You can see now that this completely changed going from steel to wood, because now you have the parameters that you need for wood design, such as the wood species and all of that. And we chose 2x12 that worked for what we're trying to do. So you can have all of that information here wrapped up in one nice calculation, and you can do up to 12 beams in one calculation here. So, and you can toggle back and forth in between all of them to see all of the information that you need. So, in summary, you can store multiple simple beam designs in one module. You can use steel. You can do them steel or wood, however you see fit. You'll have granular control over beam naming and description. And of course, this is a more efficient and organized workflow, especially if you have one of those buildings that you have maybe 30, 40, 50 even different designs where they're simple, but they're just a lot of different designs. So that's kind of the workflow tips and tricks portion of our presentation today. We move on to the prepared Q&A that was previously submitted by our users. So we picked this question, and we get this question a lot, so I figured it would be good to let everybody know about it. So, can a user set the default values for a module? And the answer is yes. Users can set the default values. You name it, from bracing conditions or FY, or even the starting beam size or column size, whatever allowable deflections that you like to see every time or you like to use as minimums. So a lot of these values can be set as a default value, so you don't have to adjust it every time you start a calculation. So in order to do this, it's very simple. You open the desired calculation module. So for example, let's say it's a steel beam module. You go ahead and you open it. And let's say I want to adjust the FY value. So you can adjust it. And before you don't click save, don't do anything. You just click on this tab right here that says settings on the top left corner. You click on that, and then you click on default values. That will take you to this beam. This is the name of the module that you're adjusting, and you already put the default value. You already changed, for example, FY from 50 to 36. Then all you need to do is just click save. This will be, once you click save, then you can exit all of this, and every time in the future you open a steel beam calculation, it will start with that default value. So to show you this in action, what we're going to do is we're going to just flip here to ENERCALC. I'm going to pick, for example, I'm going to pick steel beam. And as it opens, I am going to switch from 50 to 48, just to kind of make it easy. So I'm switching from 50 to 48. I haven't done anything. All I need to do, I just need to come to the top left corner where it says settings, and then I need to click on default values and then click save. Once you do this, you don't have to do anything else. You can just click cancel. Now, if I go and open a brand new steel beam calculation again, you can see that the default value that's coming out, now it's 48. It's not the 50 that it normally starts with. This applies to bracing. This applies to the size that you want to start with here with your in your calculations. It applies to a wide range of things. And this is not just for steel beams, obviously. This is for all of the modules, the wood module, or if you like a particular wood species that you commonly use in your area, you can just have it there. One of the things that I typically do is that I adjust this to say completely unbraced. And this is because a lot of times when the new engineers, younger engineers who start a calculation, a lot of times they just put a size and they're busy with everything else, and they forget about the bracing conditions. And then we end up with an answer that, that they're saying it's completely braced, but it might not be completely braced. So this way we might end up with a beam size that doesn't actually work. But if I always have it completely unbraced as the default, then every time they do the calculation, it's either I am extremely conservative Or worst case scenario, it'll tell them that this beam is failing, which will prompt them to look a little bit more into why the beam is failing, and then they can come back here and remember that they haven't set the bracing information. So, anyways, this is just a simple walkthrough of how we set default values, and this is truly applicable to a wide range of applicable to all of our models. Modules that you use to set default values. So now we move on to our next part of the presentation, and that is live and dynamic load linking. So ENERCALC newest build includes a new feature introduced in the steel beam module, and this is load linking. So load linking is now a native feature within ENERCALC. You can take reactions from one member and you can link them to apply onto another member. ENERCALC also understands the load path, and it provides warnings to users when changes that affect the reactions or dependent calculations occur. So if beam 1 sits on beam 2 and then something changes in beam 1, it'll automatically understand that the reaction now updates and we need to bring in a new reaction. And it understands all of the load paths. So if you have 3, 4, 5, 6 beams connected to one another, it understands the order of the connection and it understands how to tie them all together. And of course, yeah, so it's intuitive load linking process with powerful graphics and granular control. So to walk through this, I'm going to kind of go through it a little bit in the slides, and then we're going to jump into ENERCALC to demo it live and answer some questions. So the first part here, you will notice in the steel beam module, you can see the newest and freshest tab, which is the linked loads tab. Now, when you click on the linked loads tab, you will see this new window with a lot of information to unpack. So we're going to focus on the top half right now, and you can pick your reactions. You can actually pick them either from beams or from columns. The current build only supports reactions from steel beams, but the columns will be a future development. So if you look on the left-hand side, you will see a list of all of the beams that we have in this project file. So I already created a few beams, and then now all of the beams that I've created, those are the options that I can grab a reaction from. On the right-hand side, you will see a 2D diagram of the beam that you select. So if you select this beam, you will see this diagram that will help jog your memory a little bit. So this way, because sometimes, the naming is, sometimes the naming convention is not very standard across the company employees. So it could be beam 1, beam 2, beam 3, but it means nothing. So having this right here will help jog your memory a little bit, understand, okay, this is a 12-foot span. Oh, I remember this. This is the side beam. This is the one that I want. Now, you would also have this table right here. This is a table of reactions. So you can see here, this is support 1, and this is support 2. Since this is simply span, so you can have here the reactions are the same in this case, but otherwise you will see the correct reactions. If you click on another beam from this list, this 2D diagram and, of course, the corresponding reaction table, both will change so they can match the beam that you selected. So if we jump from beam 1 to transfer girder number 2, you can see that it completely changed. This is a whole different thing. And now you look at it and be like, oh, this is the one that I want to grab reactions from. So this is a quick way for you at least to know what you're trying to link, instead of having to go out every time and figure out the name of the beam exactly. Again, especially if you have 30, 40 beams right here, this really becomes very useful. So now we go back to beam number 1, because beam number 1 is the one that we're trying to grab the reactions from. What happens here is that, again, beam number 1 has 2 supports, and I'm trying to grab reaction number 1, for example. So I'm just going to click on it. Once you highlight it, you can come down here to the lower portion, and this allows you to control the location and the application of the load. This right here is a neat little feature, and this asks you, how many times you want the load or the reaction applied at each location. This is useful if you have, for example, if you have an exterior girder, that like a perimeter beam that's receiving standard beams, then the reaction is coming only from one side, and that's why you only need to apply the reaction once. But if you have an interior girder that's receiving a uniform reaction from the right hand side, and it's also receiving a reaction from the left hand side, and if those reactions are the same, all you need to do, you just need to click 2 here, and now it'll apply the load twice. So this will help you instead of having to relink every load, from the right side and then from the left side. Especially if they're the same, then you can just use this multiplier. And this portion allows you to select the location of the application. Of course, you can put it at quickly, mid-span or third points. You can also specify an exact location, like saying I want to apply it at 2.5 feet from the left support. Then you can just apply it that way. Or you can apply it as a repeated load. So for us, in this case, I want to apply it based on a specific spacing, start at 0, and then every 4 feet on center. And once you do that, once you have this set up, all you need to do, you click on the link load. Once you click on the link load, this will show up right here, because this table right now shows you the loads that you have linked, or the reactions that you have linked into this calculation. So right now, we linked this calculation right here, and you can see it, the reaction of 3.4, 6.2. It's the same thing, 3.4, 6.2. And we applied that 4 feet on center, so you can see this in the 2D diagram automatically updating for you. So all of that load is automatically applied. Another thing to talk about a little bit regarding this linked reactions table, you have a little bit of control here that that you can, for example, unlink a load in case you change your mind. You can copy a load if you have the same load again. You can copy it, and of course, sometimes you want to reorganize the order of these beams that are linked, just to make your life a little bit easier. So you will have a little bit of control to do that as well. And with the introduction of load linking, we had to introduce a little bit more statuses, or a little bit more indication for the user, so they know if everything is up to date or things are not up to date. So what we did, we introduced a new badges to indicate the status of the linked load. So you can see here, this is new. This is something that we didn't have before. Those are the statuses, or the badges that indicate the status. And this is the legend right here. So the legend explains the meaning of each status. You have green. This means that all links and calcs are up to date. Yellow means that something has changed in an upstream calculation. Hence, the beam needs to recalc. So for example, reaction from beam 1 goes into beam 2, or goes into the primary girder. If beam 1 reaction changes, the primary girder is going to flag you and say, hey, you need to recalculate me because beam 1 changed. Now, the red status, or the red badge, this indicates that the previous upstream calc needs to be updated. So this one right here is saying that the one before me needs to be updated, and this one is saying that the one before me needs to be updated. So this just tells you that if you have these badges, honestly, anything that's not green, then you need to be able to, you need to recalculate. And in order to do this, we have, and you can do it manually one by one, but we have introduced a new button, which is the recalculate linked loads button. So if you click on it, it will perform recalc on all of the beams in the correct order, because it understands the proper order. It follows the proper load path, and it will bring all the calculations up to date. That's what it looks like. When the calculations are up to date, they're green. They'll have a green status, or green colored status. So one thing that I want to stress here, this is extremely important. It is important to note that these badges have nothing to do with the status of the design. This green badge does not indicate that the beam is passing. This badge only indicates that all of the linked reactions are up to date and the calculation is up to date. The result the result from this calculation could be a passing member or it could be a failing member. The badge doesn't know anything about the status of, pass or fail. It just knows one thing. It knows that you are using the most up-to-date reaction. The reactions are linked properly. Now, whether the beam passes or fail, this still your responsibility as an engineer to check it out. So without this is kind of a quick introduction to load linking. And what we're going to do right now, we are going to take it for a spin. So let's jump right here. So I already created a few calculations. You have beam 1, you have primary girder, you have transfer girder 1 and transfer girder 2. So this is the order. Beam 1 puts a reaction on primary girder, the girder puts a reaction here, and so forth. Okay. So what I want to do today, I want to just take you through the process of just linking loads and kind of and see how versatile it is. So the first thing we want to do, just click on steel beam. And once you open a steel beam calculation, I'm just gonna open this and I'm gonna call it test 1. And we're gonna keep everything here the same, just ASD 50 and just fully braced. I'm going to change the size to something a little bit bigger, 18 by 97. Span loads, I'm intentionally keeping, let me open this. I'm intentionally keeping this blank. So this way, when we apply a load, you're not going to get it confused with something. When we link the load, you're not going to get it confused with an applied load. So we're just going to jump all the way to linked loads. This is the list of the girders that we have, or the beams that we have. You can see how they dynamically change. And you can see here the linked reactions also updating as we go. So what I'm going to do, for example, I am going to pick the reaction from support 1, and I'm going to apply it at a specified, let me change the this right here. I'm going to say this is 14 feet, and I'm going to apply this reaction one time at 2 feet. And here you can tell, so this is from the full beam right here. So starting from the left support right here. So once I click on link, you can see right here, it already applied and it's right there. So I'm going to do the same thing again, but I'm actually, let me take another reaction. And I'm going to take this and I'm going to actually apply it twice. And I'm going to apply it at, let's just see here, 3.5 feet. And I'm going to add it right here. You can see it's already applied. And if I just delete this for a second, you can see that it says 2 by. You see that? So that's you're getting 2x. You're getting twice that load. So assuming that we have this, let's say that I decided that I want to increase the span. So let's go ahead and just add another beam next to it. Let's say this is span number 2, and maybe this is 9 feet. And now let's go to linked loads, and let's grab this reaction. It's a big reaction. So I can do a variety of things. If I click, let's say if I want to apply this at mid span, it's asking me, do you want it to be at all spans or at a selected span? If I say all spans, it'll apply at a mid span here and mid span there. And you can see it just like that. Or I can click on it and say, apply it just to the selected span, which is the second one, and just do update. This one will disappear, and now you only have it there. So you will have a lot of control as you go. Maybe I want to add another end right here, and I'm going to make it free end, and I'm going to turn this into maybe 4.5 feet. And maybe I want to link another reaction. And this is something now you see here. If I say beam, then I can apply a load all the way from starting the calculation or starting the distance from this point. So if I want to apply the load at 1 foot into this beam, this could be 15 feet. Okay, so I can just say here 15 feet, and I can apply it, and it'll show up right here. Also, let me unlink it. Also, what I can do, I can just go ahead and say, instead of applying it, from the beam and start calculating from here, I want to apply it at 2 feet from span number 3. So I select the span, make sure that the span is selected, and then click on this. And then now, if I want to say 6 feet, it won't let me, because it's going to say, I'm sorry, because it's going to say that, let me do this one more time. So if I want to apply this at 6 feet, it's not going to let me do that, simply because it's already too much beyond the 4.5 feet. There's no space to put that. So that's why you can apply the load directly from the left hand side and say, I want to apply it at 10 feet, 12 feet, 13 feet, or you can specify it from a reference point, which is the span point. So I'm just going to go ahead and apply it at 3.5 feet from this end, and that will put us all the way right here. So you can really play with this. You can move these loads up and down for order wise. You can unlink them. You can do a variety of things. You have plenty of control over how you want the loads applied. And then once you're done, we can go ahead and click, maybe this size 18 by 97, that's an overkill. So we're just gonna change the size to something a little bit smaller. Okay, so 14 by 34. So you click save, and now you have it right here, and everything's fine. Now here's what I want to do. I want to go to this original beam, because everything, or a lot of these calculations, link to this beam. So if I go here and open this calculation, we are going to try to change some of those reactions. So what I'm going to do is I'm going to adjust the loads. So from 70, maybe I'll just turn it into 90 PSF, and that kind of will change the reactions. So we know that this beam, the reactions from this beam are linked into the other beams. So if we save and close, you can see right here now the statuses have changed. This one became orange because it's asking you to recalculate. This is because it's directly related to the upstream beam that changed. And then those ones are red because each one is telling you that the previous calculation needs updating. And then this one's telling you the previous calculation needs updating. And then the same thing here. And then this one's saying that you need to recalculate me. Now, what you can do at this point is that you can just do everything one at a time, where you can update each calculation one at a time. But the quickest way to do this is this new button right here, which is calculate linked loads. If you click on that, and the system recognizes there are 5 beams in here, so we're going to go ahead and just recalculate everything, and then finally it turns into green. This is the point that I wanted to stress out a little bit more, is that this green status just means that the loads that we're linking are up to date and the calculations are up to date. Now, this is not telling you it's passing. So here, for example, if we go to this calculation, this is green. It's just saying that the load that you have on it is accurate, but you see it's not passing here. So let's go ahead and maybe do something else. I'm going to go ahead and make a change here. So if I go ahead and open this calculation, and I'm going to change this to a W18 by 50, so it's a little bit better. And what I'm going to do is I'm going to link additional loads. So you can see here these 2 parts. This is telling me that you cannot link from this, because this is going to be a circular load, because we're putting loads into this, then we can't just grab load from it. So let's say I'm going to grab load also from beam 1. So you click on it, you click on this reaction, and right now this is what we have. I'm just going to go ahead and say I'm going to apply this reaction at mid span, or actually here, we're just going to apply it at maybe 18 feet. That looks good to me. And I'm just going to click OK. that load now applied. I'm going to click Save and Close, and it's going to show us the same exact thing. It's saying that the beam above it is fine because nothing changed there, but the beams downstream from it need to be recalculated. And I'm showing these calculations in the calc order right here. So this is a new tab. You can actually click on division, and that's your standard calculation. And you can kind of flip them up and down. But what I have them right now here, I have them in order based on where the load is going. So what I'm going to do, I am going to do, again, recalculate. And it's saying that it's only just these beams that need recalculation. The other ones don't need recalculation. So you can do this, and now you can go back and see this beam, is struggling, which is the beam that we just did. This beam is fine, and this beam is struggling. So the bottom line is that when you have a green badge here, this does not equate to the beam being safe or not. This has nothing to do with design values. It's only focusing on whether the reactions that we're linking are up to date or not. And with that, I'm gonna go to the next part of our presentation, which is the live Q&A, and Seth will be helping me out with that, the live QA part.
We had a good handful of really good questions. I had a question earlier from Mike. When you use up to a certain span, how do you account for deflection and camber? I just want to clarify what Mac was talking about in that example. Using up to a certain span is not explicitly a feature of multiple simple beam module. He was just talking about the way he had laid out his framing plan, and that he was characterizing his framing plan with a couple of primary controlling cases that would cover everything geometrically up to that span, engineering-wise, for his framing plan. And Mac, feel free to jump in if your audio is good. But I'm going to go ahead and keep going through our Q&A here. Do you have a program? Another question from Mike. Do you have a program to check for vibration in floors of different types? So this is a question that we get frequently. We do not explicitly have a module right now that does the AISC design guide process for girder mode and joist mode floor vibration. But that is something that we see from time to time in feature requests from customers. And so if that's something you're interested in seeing, be sure to reach out to the support team, support@enercalc.com. That's how our director of engineering tracks what there's demand for, what customers are interested in. And that's how we set development priorities for the future. So if that's something that you guys are interested in, then be sure and send that into the support team. Also had a question from Ed. Can ENERCALC analyze steel bar joists? So I'm going to answer this question in a couple of different ways. There's a couple of different ways you could tackle this. So if you're talking about simple analysis, definitely the answer would be yes. And I highly recommend that you take a look at the general beam analysis module. So if you look on the landing page where Mac kept going to add new calculations, under the analysis tools, you have your frame analysis, your 3D finite element, but you also have the general beam analysis module. The general beam analysis module gives you all the same capabilities that you have in the rest of your beam modules, but it's basic analysis. It's not doing code checks or strength checks. So general beam analysis gives you the ability to go in and you can set cross-sectional area, you can set moment of inertia, you have control over all those properties, and then you can go ahead and get deflections, you can get shear and moment, you can get reaction forces, even if it's something like an open web bar joist, where you're not doing full-fledged analysis. Now, if you're looking at the possibility of doing design, then you could possibly look at either the 2D frame module or ENERCALC 3D in order to do an actual detailed design check where you're checking axial capacity and so on. So if you're looking at doing steel bar joists, there's a couple of different things you could do with that. But for simple shears, moments, and deflections, you absolutely could just tackle that with the general beam analysis module. So we've got more questions rolling in, and I'm just going to keep plowing through these. Again, your Q&A is in the lower right-hand corner of the screen. If you have more questions, feel free to pile on with those. Question from Patrick: is there a way to save the image of the floor layout with the beam title in the module? So this is a great question. Mac was showing just a PDF drawing set for a recent project that his company has been working on. And if you wanted to associate that to your ENERCALC project, you can do that using the ability to embed external items. So I don't know if that's something that you guys are familiar with, but I'll just show that real quick. Let me throw up a screen share here. And if you guys look in the same place where you go to add other calculations, if you come to your add dialog, you have the ability to link external items or even scan a document. And so you could use this capability to add something that doesn't occur natively in ENERCALC, but you can associate it to your project file, store it with your project file, and do that with a variety of different files, whether that be hand calculations, whether that be an Excel file, so on and so forth. So in answer to Patrick's question, there are definitely ways that you could take a sketch, even a sketch with beam labels or calculation labels, and associate that to your calculation package so that it goes along for the ride. Good question. Question from Ashot. Please give us a time frame for ASCE 722. So I can tell you, we don't usually announce release dates because things can change over time, and we don't want to promise something and then have people be frustrated waiting on that. ASCE 722 loads and forces modules are in active development right now. That process is moving forward, and you can definitely look for those to be available soon. We don't announce exact release dates, but it's in progress, and the dev team and engineering team are working very hard to get that out to you guys. Question from Jill. Did you say that load linking was only for steel? Will it be introduced to wood or concrete? So load linking for steel beam to steel beam is the initial release. That's the very first version of load linking that's available. That's available right now. A lot of other modules are going to get integrated to load linking very soon in the near future. So keep an eye out for that. The dev team and the engineering team are pushing on that right now to move load linking out into a variety of other areas. In fact, if I go into my steel beam module right now, if I hit steel beam and I go navigate to that the link loads tab, right now you may not have noticed the tab that Mac was working on were linking reactions from beams. And if we move over here, we can see that there's a from columns tab as well. And there's a note here to all our users: the ability to link reactions from other calculations is under development, and to make your voice heard, please use the button below to go fill out a survey. So there is a survey active right now. If you're on build 7, 8, or newer, then you'll be able to access the survey. I think this link has also been going out in email responses from the support from the engineering team. You can access the survey and you can go basically vote about which modules you're most interested in seeing integrated via load linking. And that process is continuing ongoing right now. Jill also asked, can you link loads when you use multiple simple beam? And that kind of falls in the same category. Those integrations are continuing to expand and mature. And we look for more modules to continue being added over time as we go. Good question. So the answer in the long term will be yes on nearly all of those modules that make sense to interact with load linking. Fabian asked, does ENERCALC have any plans for future API integrations? So the absolute number one API integration we want you guys to be aware of right now would be ENERCALC for Revit. If you're not familiar with ENERCALC for Revit, that's probably going to be a future office hours topic, so keep an eye out for that announcement. ENERCALC for Revit is basically a seamless integration with the Autodesk Revit environment to let you launch ENERCALC calculations from Revit take those out into your calculation environment, interact with your calculations, do everything you need to do with those, and then save and close and push design information seamlessly back to your Revit environment, back to your Revit environment. So that's definitely something to look at. And we do lunch and learns on that topic as well. If your engineering team is interested in having training on ENERCALC for Revit, having an introduction to that, just reach out to us and let us know. Scott asked, is this and other sessions recorded and available for viewing? The answer is yes. We do make a full recording of our office hours sessions. Those will be posted afterwards. And I think everyone who attended gets notified of that. Are there plans to bring, Tahir asked, are there plans to bring load linking feature to the Woodbeam module? Absolutely. All that is in progress right now. And again, visit that survey to make your voice heard. A lot of people asking the same thing. Is load linking planned to be implemented in different beams? Absolutely. Definitely that will be. John Paul asked, yes, if you joined late, there is definitely going to be a recording. Mike asked, can you give us an option to move point loads around for each calculation module? And basically, that's exactly what we're talking about today. Load linking is going to continue to expand across the ecosystem and give you a lot of broad capabilities to interrupt those reaction forces as applied loads in a variety of your different modules. Steve asked, when will you provide training on walls or foundations? Definitely reach out to office hours at enercalc.com. Mac takes care of all those requests, and that's kind of how we gauge the interest of the topics that engineers are interested in seeing training about. So if you'd like to see a session on a specific topic, absolutely reach out and let us know about that. Mike asks, can beams allow for biaxial loading for beams that also have out-of-plane loads? So yes and no. You do have that capability. It's not explicitly incorporated into the beam module, but you can synthesize that behavior with a column calculation at this time. That's on a list of feature requests. We know that that's a thing we hear about from time to time from customers. We'd love to be able to do biaxial or what have you. And so just know, it's on our radar, but in the present day, if you have that challenge today and you need to tackle that, you can almost always tackle those situations with a column module because the columns can do biaxial bending and axial compression at the same time. When will retaining wall and other modules allow for multiple point loads? I don't know for sure that there's plan to make those changes, but definitely reach out to the support team if you have a specific question about that. One of the things about retaining walls and other wall modules is that most of those are analyzed with a unit strip approach. And so that may not have the same point load behavior that you're expecting with something that's more discretized. But be sure to reach out to the support team if you want to dive deeper on that. With that, I think we're pretty much at the end of the hour here. And I think we're going to go ahead and start to wrap up. Again, we are doing this as a monthly session. And so we're going to have future sessions with more opportunities to ask questions. And we'll have more content coming out and probably tutorial videos and on LinkedIn as well about load linking. Be sure to watch out for notifications for next month's office hours. And like Max said, load linking is active now in your current latest build, the build that was released on 708. So be sure and check that out. Reach out to us if you have any questions about that. And we thank you, everybody, for being here. And we'll look forward to seeing everyone next month as well. We'll have announcements going out for content next month. And we'll look forward to seeing everybody then. If there was any questions you had that we didn't get to, you can always send those to, I believe it's officehours@enercalc.com or to the support team, and they can find their way around to office hours as well. So thank you all very much for being here. We appreciate everybody, and we'll look forward to seeing you guys next month.